In this video, we're going to have a look at the three inverse functions and how to sketch them. First of all, the three inverse functions are arccos x, arcsin x, and arctan x. A lot of people confuse these with the reciprocal functions. So to make it clear what they are, I'm going to put a quick equation on the board and we'll have a look at how to use the inverse function. Suppose I have sine x equal to a half and I would like to work out what x is. That means to solve this I need to make x the subject of the equation. I need to get rid of this sign to undo it. To do that, I apply the inverse of sine to both sides. And the inverse is arcsin. There we go. I've applied arcsin to both sides. Now arcsin and sine are inverses of each other, so they just cancel out. And we get x here. On the right, we've got arcsin of a half, and you put that into your calculator and you get your answer. Well, some of you will know this anyway. But just to be clear, your calculator probably doesn't have the function labelled as arcsin. It probably has it labelled as sine minus 1. But on the calculator, where you see sine minus 1, it actually means the inverse of sine. It means arcsin. It's a little bit confusing because some people can interpret this as 1 over sine, which is not the inverse of sine, that's the reciprocal. Okay. But when we're writing the maths, to express the inverse, we're always going to use arcsin or arccos or arctan. Right. And now to sketch the inverse functions. Firstly, to sketch arccos. Well, arccos is the inverse of cos, and you can sketch any inverse by reflecting the original in the line y equals x. So if I reflect this blue line in the line y equals x, I'm going to get arccos. But there's another issue here, which is the type of function cos is. Cos is actually a many-to-one function, i.e. there are many x values mapping to one y. I'll give you an example here at pi over 3 and 5 pi over 3. Okay, they're both mapping to the same y value. So there's many x's mapping to one y. The trouble with that is that when you do the inverse and you go from the range back to the domain, you're going to have one y value mapping to many x's. And that's not a function. So to deal with this problem, we change cos x so it becomes a one-to-one function. And to do that, we restrict the domain. If I cut the domain off after pi, to get rid of this bit of the curve, let's get rid of this as well. And if I cut it off before 0, there we go. This section of the curve is now a one-to-one mapping. And one-to-one functions do have an inverse, so all I need to do is reflect this line in the red dashed line. Okay, here we go. So it's quite difficult to do actually, but there we go. Alright, and here we go for arccos. The domain of arccos is the range of the original, so from 1 to -1. It's not quite symmetrical. And the range of arccos will be the domain of the original, so 0 to pi. There we go. Okay, on to arcsin. Again, we're going to reflect sine in the line y equals x. There we go. But we've got the same issue with sine. Sine is also a many-to-one function. So we're going to let's just restrict the domain in the same way. So first of all, I'll cut this curve off after pi. There we go. All right. But you've probably noticed, even from 0 to pi, it's actually still a many-to-one mapping. If I take 2 points here, they go to the same y value. So I'm going to have to restrict it even further. So I've got from 0 to pi over 2. Now that's a very small domain, and its range is only from 0 to 1. So to make sure we're mapping from -1 to 1, for sine we're gonna consider the curve from minus pi over 2 to pi over 2. And there's our curve that we need to reflect. Alright. There we go. Okay. The domain of our inverse is going to be the range of the original. 1 minus 1. And our range here will be the domain of the original. Minus pi over 2 to pi over 2. Brilliant. X, Y, X, Y. Alright, and finally we've got arctan. Well, let's have a quick look at tan. Same problem, tan is also many-to-one, so we're going to restrict it. We're going to cut off everything after pi over 2. There we go, let's get rid of all of that. Let's get rid of the asymptote. Okay, and everything before minus pi over 2, which leaves us with this curve here, which is a one-to-one function. We need to reflect this in a line y equals x. Alright. Whenever you're performing transformations on a curve and it has asymptotes, it's usually easiest to sketch the asymptote first. So this one here, pi over 2, when we reflect it, it's going to go to y equals pi over 2, and minus pi over 2 is going to go to y equals minus pi over 2 down here. Cool. And then finally we've just got this curve to sketch. And there is arctan of x. Its range, its domain is all of the real numbers, and its range is anything between minus pi over 2 and pi over 2.